So here the question is, if x is equal to root of a raised to sine inverse t, y is equal to root of a raised to cos inverse t, we have to show that dy by dx equal to minus y by x. Although the question is to show that, we have to find dy by dx and show that it is equal to minus y by x. X is in terms of the parameter t, y is also in terms of the parameter t. So what we have to do is parametric differentiation. So we will take first y. Y is equal to root of a raised to cos inverse t. So calculate dy by dt. What is the outside function? Outside function is the root function. Do you remember d by dx of root x? D by dx of root x is 1 by 2 root x. We have by-hearted the formula before itself. So d by dx of root x is 1 by 2 root x. So here it will be 1 by 2 into root of a raised to cos inverse t. Okay, into, again what's the next function? So root function derivative we have took for root function. The next is a raised to x, that is of the form a raised to x. What's the derivative of a raised to x? Do you remember? Derivative of a raised to x is a raised to x log a. A raised to x log a. The same function repeats here into log a. That is that is the derivative of a raised to x. So here what we have to write? A raised to cos inverse t. We have to write the function as such into log a. Okay, so again a raised to x is a raised to x log a. Instead of this x we treated cos inverse t, isn't it? So we have to take the derivative of cos inverse t. What's the derivative of cos inverse t? Minus 1 by root of 1 minus t square. Minus 1 by root of 1 minus t square. Is it clear? First what you have to do is, the outside function is root. Root function derivative is 1 by 2 root x. So 1 by 2 root a raised to cos inverse t. Again what we have to do? We have to take the derivative of a raised to cos inverse t. A raised to cos inverse t is of the form a raised to x. What's the derivative of a raised to x? A raised to x derivative is a raised to x into log a. So here it is a raised to cos inverse t into log a into, we treated cos inverse t as x. So we have to take the derivative of cos inverse t also, that is minus 1 by root of 1 minus t square. That is equal to, so already a minus is there, 1 by 2 into, what is this root of 1, a root of a raised to cos inverse t? That is the same as y, isn't it? So instead of this term, I am replacing by y. Okay, into, if root of a raised to cos inverse t is y, what will be a raised to cos inverse t? Can you guess? If a root of a raised to cos inverse t is y, what is a raised to cos inverse t? It will be y square, isn't it? Just square this equation. Y square is y, the square of y is y square, and square root of a raised to cos inverse t whole square will give you a raised to cos inverse t. So instead of a raised to cos inverse t here, we can write, instead of this term a raised to cos inverse t, we can write the value y square into log a is there, divided by, minus we already wrote in the first, root of 1 minus t square. Clear? Again what we can do? 1 y get cancelled. So the balance in the numerator is minus y log a divided by 2 into root of 1 minus t square. Let it be there. Again take x. What is x? X is equal to root of a raised to sine inverse t. A similar term like y. Okay, so do the derivative. Dx by dt is equal to, what is the outside function? Root function. What's the derivative? 1 by 2 root a raised to sine inverse t. Okay, into, what is the next step? We have to take the derivative of a raised to sine inverse t. What is a raised to x? Derivative of a raised to x is a raised to x log a. So derivative of a raised to sine inverse t will be a raised to sine inverse t into, again we have to take that, into log a into, again we have to take the derivative of sine inverse t. What's the derivative of sine inverse t? 1 by root of 1 minus t square. Okay, again 1 by 2 into, what is this root of a raised to sine inverse t? That is the same as x. So I am replacing it by x into, what we can write instead of a raised to sine inverse t? X is given as root of a raised to sine inverse t, isn't it? So a raised to sine inverse t will be square of this term. So left side also we have to square x square. So instead of a raised to sine inverse t, I can give the value x square. So x square into log a into 1 by root of 1 minus t square. Again what we can do? 1x get cancelled. So what is the numerator? X into log a divided by 2 into root of 1 minus t square. That is dx by dt. Okay, again what we have to do? The last step is find a dy by dx. What is dy by dx? dy by dt whole divided by dx by dt. What is dy by dt? We got the value as minus y log a divided by 2 root 1 minus t square whole divided by dx by dt. Dx by dt is x log a divided by 2 into root of 1 minus t square. The numerators denominator and denominators denominator are the same. So completely we can cancel, isn't it? And the balance we are getting is minus y log a in the numerator by x log a. Again you can see similar term. Which one? Log a. This also can be cancelled, giving you the answer as minus y by x. That was what we have to show. The question was to show that dy by dx equal to minus y by x, and we got dy by dx as minus y by x. And the last answer you have to write as hence proved.